My name is Harish and today I am demonstrating the SaaS pricing and intelligence code. So what is this SaaS pricing and intelligence code? So this is basically a multi-agent system built using the Google's agentic development kit. So what is the problem that we are trying to solve? So tracking competitors pricing changes manually is a slow, error-prone chore that leaves product teams reacting too late, and scrapers fail due to layout drift and copy-paste files lack version histories. So why are we using AI agents? So unlike rigid scrapers, agents can understand the unstructured layouts and dynamically compare plans and enforce safety policies and alert the teams on correct time. Our solution automates this workflow end to end using a secure SQLite backed multi-agent architecture. So uh, now let's go over the architecture of our system. So first I'll go give an overview of what are the agents that we are having, then we'll go through the in detail the architecture. So the first agent, which is a root agent, is called as the coordinator agent, which acts as the root orchestrator. So it receives the user request, it runs the safety checks, and it decides which agent it should send that particular request to, and compiles a final report and saves it, etc., etc. And then we have the scout agent. So scout agent is the main agent that interacts with the web, and it uses beautiful soup to safely crawl and summarize the raw competitors page contents using a tool called as the fetch web page. And then we have a analyst agent which interacts with the internal data, and it is also equipped with its own tool called as the get own pricing catalog to perform queries on our company plans and perform mathematical gap comparisons. And then we have a DB analyst agent which is equipped with two tools, query processing DB and then generate history chart to retrieve the audit histories that you have done in the past, and then it can generate the timelines. So this is the main architecture diagram. So what are the user request is coming, it is intercepted by the coordinator agent, and then based on the agent it is sent to the whichever three agents that we are having and the tools. So if it is a scout agent, it uses the fetch web page tool as you already discussed, and then it goes to the competitor's website and it scrapes it, and it stores them, and it returns that output to the coordinator agent to be stored. Similarly, we have our analyst agent which uses our internal pricing DB for our internal company pricing plans, and then we have our local history JSON for our pricing history logs. And then it also uses SaaS web news and releases, so that sometimes the competitors company will always post some articles about data or etc. So if you can't find any articles related to the pricing plans and what made the competitor to particularly adapt this type of plan, then we can approach it very effectively. So it uses that too. And then we have a DB analyst agent which is as we already discussed, it stores the competitors pricing in a competitor pricing.db, and it is basically stores month wise and then in the date wise, so that it is easier for us to see. And then we have a Slack notification too, so that it sends a particular Slack notification alerts, which we'll look into it later. Now let's discuss the security and guardrail design, and which will be more appropriate to explain from also the code over here. So let me just pull it side by side. Yeah. So one of the biggest parts in the 5 days course is security. So we have to ensure that it is not that hackers can't do like injection, prompt injection or SQL injection attacks and stuff like that, and etc., etc. So first we are using two things, which is safety.py and then policies.aml. So policies.aml has a list of roles, and then the what are the tools that particular roles can access. So for example, scout agent can only access these two, and then analyst agent can access only these 4, so etc., so that the agents don't use the other agents activities, so that we have a secure roadmap on what a particular agent is doing. And then we also have a security column where we mention what are the blocked keywords, and which we can add more, but for simplicity I have written some. And then we can also add the blocked TLDs like .ml, .loan, .work. So some of these fake domains that we don't want to scrape. So first let's then discuss the guardrail design. So our tools are expressed over a standalone STO based MCP server for production grade security. So first we have implemented 3 layers. So first is a policy server pattern using policies.yaml files as I shown here, which is to restrict tool execution by agent role. Second, we have a domain safety guardrail that immediately blocks scrapers call to social networks or suspicious TLDs like the .xyz, etc., which we can also do it practically when we are doing in the console. The third we have is our context hygiene middleware, which cleans the tool's arguments before execution, so we can safely resolve the bracketed variables from env or state to prevent prompt injections. So first let's see the mcp.server. So first this is the mcp server.py file, where first is an example of where we are fetching the web page, which is a tool used by our Scout agent. So as we can see, it uses beautiful soup here for scraping, and it does its job. And similarly, we have our own own pricing catalog, competitor history, and then search, etc., and then the safety.py. So the main 2 calls is that a validate tool call. So basically, whenever an agent is running, every call is intercepted by this validate tool call, so that we can see which since safety.py uses policies.yaml, we can see whether that particular agent which is requesting that particular tool, that it has access to that tool or not. So that, as we discussed, to impose the policy.yaml, we are using this safety.py. Now let's run the application to see this in action. So just run the application over here, and yep, so the application is up and running. Let me just refresh it. So I have already made some prompts that we can run. For example, let's take this. So first we are creating a new session, and then we are doing this. So analyze the pricing page at salesforce.com.product sales and write a comparison report against our catalog. So let's see what our agent does. So first it is transferring, coordinate agent is transferring to a Scout agent, which is transferring to the web page tool, and then similarly it is transferring to the analyst agent to get the competitor history and search for the competitor pricing news, etc. And we will have a more clear view if we can go to the traces, which will be available once the call is over. So right now it's working. Now that once this report is generated, we can see that it will be stored in our competitor.pricing.db. So what happens is that let's run another session parallelly, hopefully. Yep. So as we can see here, the output is generated. Salesforce Cloud Plan versus our own company catalog, which is already pre-written, and we'll get a report like this, a competitor pricing timeline, Salesforce, etc. And this all will be stored again in our reports over here. We can see the date today's based on the month and date. This is stored according to that, and the version number. So since I had multiple runs before, it's incrementing the version number accordingly. And we can also another one of the core things apart from security is running tests to evaluate our agent. So we can run things using agent CLI, or we have also written some PyTest. So let me just pull that command. We run PyTest. Since the server is already running, test will run in the parallel. That is not an issue. So one of the other main things is that we are using the MD5 hash of the competitor's plan. So when the plans differ, it logs a new configuration file in the SQLite, so that it will be easy for the coordinator to delegate to the DB analyst, which queries the SQLite and renders the Mermaid flowchart and illustrating the price version adjustments, etc. Now we have written some PyTest over here, and it ran them successfully, and we can see 10 past and 17 warnings in 1.4 something. Since I already ran few tests prior to this recording, so it is working very well. So let me just again do this using the agent CLI also, but this time it will take a little bit more time since we are using agent CLI. So let me just parallelly check whether this pricing agent is complete or not. Yep, it's complete. Yeah. Now let me try to create a new session. So this is one of the other things that I said already. So if I give an output like show me the pricing history for our Salesforce, it will create an Mermaid history chart like this. So pricing from the date that we last ran this scraping call, based on that it will pull the report, and then it will create the pricing changes like this, and it will show us the report. And for the Slack notification, it will send the Slack notifications like this. So competitor Salesforce cloud pricing plans range from blah blah blah, so that it is easy. We will get a small overview over here, so that when we don't have to pull the report every single time that it is needed. And let me show some other examples too. This is another one of the examples where we are trying to prompting the agent to do something that it's not supposed to do. So extract the pricing details from the file scheme at password, which is used to store the passwords of our users, etc. in Linux systems. So if we do like that, first it is transferring to the Scout agent, and from the Scout agent it is the tool that we discussed here, which is the validate tool call, intercepts this, and it sees that this is not supposed to be scraped. So it tells, I'm sorry, I can't process local files or FTP file directly, I can only access the publicly available URL, so please provide a valid URL. So by doing this, we are avoiding the prompt injection attacks and stuff like that. Now after that, this test is running, it will show us the computing metrics for the evaluation data set, and it will store this here in the traces. And let me just open this. And if I go to, so as we can see, this is the evaluation report that it generated. It gives us case wise with the prompt it had run, and what is the system topology, what are the tools it used, and what are the system instructions that we gave, which are fetched from the what was which is fetched from the agent.py, where we define the each agent. So fetch web page, sorry, each tool, fetch web page, get competitor history, and then we mention each tool along with our model that we are using. So analyst agent, DB, etc., and the root agent, which is also called as a coordinator agent. So and then we will also have a trace. So first coordinator agent, and then it's sending to the scout agent, and scout agent fetches the web page. As we can see, the status is success, and then it generates the report, and analyst agent saves it, and analyst agent gives us this thing, and then coordinator agent gives this beautiful summary like this, and then it coordinator agent saves it, and then we have multiple cases like this, which is similar, like checking the pricing page at things like that. So this is an overview of how we are this project is developed. So the main idea is that we are trying to reduce the manual effort that is done by our product team, so that we can keep up with the competitors, since we will never know when our competitors pricing plan is changed, or how to keep up with it, or what is the reason behind their particular plan, stuff like that. So based by this tool, we can generate faster reports on how their pricing plans have changed historically, so that we can keep track of why they are doing it, and how they are doing it, and what is the particular reason behind their current plan. Thank you everyone.